A second topic is using the formula for compound interest to calculate some numbers. And here's the formula. Let me remind you what these mean. A is the amount after compounding. P is the amount that you start with. And it's called principal, which is probably why they use the variable P. R is the rate, the interest rate in decimal. Move that decimal point 2 places left from the percent. N is the number of times compounded in a year. And T is the time in years. Okay, so the first thing they ask us to do is use this. Our initial amount is 2,100. It's at 6.5% compounded quarterly. So, because I have the equation right above, I'm not going to rewrite it, but we are going to write what we're using. So P equals 2,100. R equals 0.065. And compounded quarterly, there are 4 quarters in a year, so N equals 4. Plug that in. And calculate. And we got NT, so 4 times T. No, sorry. Yeah, plug it in. There's our equation. And now we're going to use it to find the amount of money in the account after 5 years. And 4 times 5 gives me 20. That just saves me some typing on the calculator, which I'm going to do here next. All right, typed in my equation. And it looks like 289.98. We're going to round to the pennies. 2898.88. So after 5 years, our $2,100 grows to almost $2,900. All right, this one's a little bit tougher. How long will it take for the account to reach 4,200? So they're giving us A, and now we have to, well, we're going to need to use logarithms. How long? All right, so we're still compounding quarterly, so that's 4t. All right, the first thing we're going to do is to get the base of that exponent by itself by dividing by 2,100. And what do we get? 4,200. Okay, so that's exactly 2. A reminder, we're undoing an exponential equation. The only way we can do that algebraically is to use a logarithm. So I'm going to apply a log of the same base to both sides. So on the left-hand side, I'm going to apply log of base 1 plus 0.065 over 4 to 2. And when I do that to the right-hand side, and just because I don't have room, I'm not going to show it, it cancels the base of my log cancels the base of my exponent, and I'm just left with 4t. Okay, I'll go to the calculator and put that in, and I'm going to walk you through it because I want to make sure you know where to find this. So math, and if you go down, you're going to find that log of any base. There we go. Okay, so log base 1 plus 0.065 divided by 4. And I need some parentheses. Oh, no, I don't. It's going to do order of operations. It's going to do the multiplication before. It's going to do the division before it does the addition. So I'm good. And that's of 2. All right, so that tells me that it looks like it's going to take 43. No, that's 43. Let's try that again. I get 43 equals 4t. I forgot about this little division step. So it looks like t is going to be equal to 43 divided by 4. Uh, 10.75. Okay, so don't forget you need a log to solve for a variable in the exponent of an exponential. If the interest is compounded continuously, how much money will be in the account after 5 years? Remember, our continuously compounded equation, kind of similar, but our Euler's number shows up. Totally simplifies our calculations. So we're just going to plug in our beginning amount, which was 2100, e to the 0.065 times 5. All right, back to the calculator. Now I'm going to use second and ln, which will give me e 0.65 times 2906.46. Notice that we make slightly more money if we compound continuously. All right, see you on the next video.